the 9 minutes for like for the whole question, like for the whole question, like with the passage, or is it like only for the questions, or?
So 9 minutes is you want to take 9 minutes to complete the entire passage. So it always depends on the length of the passage and how many questions they're giving you. So generally they'll like you want to average 9 minutes per passage.
Okay.
So you don't want to pass 10 minutes, but sometimes they'll give you really short passages with like 1 or 2 paragraphs and 5 questions. That will like probably take you 7 or 8 minutes. So
Okay.
just, yeah, don't pass 10 minutes.
But like nine is the magic number, you're saying?
Yeah,
Okay.
so that's what I did. I always timed myself. I gave myself 9 minutes to do passages. Okay, so I guess Sim will start off with the chemistry passage.
Do you want to just go in order of the slides, or?
Okay, sure. Sorry, 1 second. I have to get the link for the questions. So I'll give you a passage that has to do with biochemistry, and I'm sending you a link of the question so that I can have the passage on my screen. Oh wait, I sent it to. Did everyone get this document?
Yep, we got it.
Okay. Oh, this is not the right slide. Okay, so I'll begin the timer for 9 minutes. Starting now. All right, that was 9 minutes. If you don't finish, don't worry. This is just a practice, but do reflect on what made you slow down. So overall, what did we think about this passage? Does everyone give it a thumbs up?
It was pretty good. The graphs really helped.
That's
The
good.
figures.
Yeah, it is lots of orgo, and I'll actually touch on that when we review the questions. So I'll show you. So this is what I highlighted for this passage. As you can see, I highlighted key terms such as anaerobic, names of products, glycolysis, which is an important process, cofactors, and enzymes. So it's important to not highlight everything, even though you may be tempted to, just because highlighting too much will make it harder to refer to the important terms or ideas. So if you want, you can screenshot this as an example of like what you could highlight in future passages. Or, I mean, I'll be sending out the slides later on today, so you don't have to redo your highlights. So for the first question, the correct answer was C. So alcohol dehydrogenase converts acetaldehyde into ethanol and oxidizes NADH to NAD+. So we can eliminate D because hydrogen is being transferred to acetaldehyde, as the passage tells us. So it's not going to decrease the pH of the solution. CO2 is produced to convert pyruvate into acetaldehyde, not acetaldehyde into ethanol. So B is eliminated. And we want to pick a specific answer that is mentioned in the passage and that's consistent with the data. So C is telling us an accurate way of measuring enzyme activity, which is observing a decrease in absorbance at 340 nanometers as NAD+ is being produced. So we pick C. And the question is asking us to pick a following measurement that best determines the activity of the enzyme, and A is a little bit too vague and it's not really mentioned. It doesn't mention a specific technique that would determine the activity of the enzyme. So did everyone understand this answer and like the reasoning for it?
Can you show us the graph again from the last slide?
Yeah. Oh, wait, sorry.
Oh, okay, gotcha.
So for question 2, it's important to be familiar with the energy coordination diagram, which is covered under the general chemistry section. So the red line in the passage shows the energy diagram in the presence of a catalyst. So the transition state is lower in energy in C than in D because catalysts find alternative pathways of lower energy. So I'll show you that. So here we can see red is lower in energy in terms of the transition state. So that will be in the presence of the catalyst. So C is the correct answer. And I highlighted the words presence of an enzyme because the question is asking you about a specific part of the graph. So it's easy to miss this or misread it as absence of the enzyme because I've done that before. So going on to the third question, you also should be familiar with the reaction coordinate graph for this question as well, but this time it's asking you for the transition state without the enzyme. So the answer is not D because D represents the activation energy. So it would be B, which represents the energy of the transition state. So for question 3, I highlighted the word without the presence of the enzyme because it's asking once again for this specific condition. Does anyone have any questions so far? Okay. So for question 4, I highlighted the word humans because they made the distinction between yeast and humans, which is very clear in the passage. So on my whiteboard, I'd write down the reaction in humans, which is alcohol dehydrogenase, converts alcohol to acetaldehyde, and also produces NADH. So immediately we could cross out A because pyruvate is not a final product. And if we recall, in yeast, acetaldehyde is converted to ethanol by transferring that hydrogen from NADH and attaching it to acetaldehyde. But in this reaction in humans, it's the opposite. So ethanol will let go of a hydrogen to make acetaldehyde. So B is actually correct, which is why it's a wrong answer, because the question is asking you which of the following statements is not true. So for B, acetaldehyde must be broken down by another enzyme so it's not built up in the brain. C is also correct because as enzyme concentration increases, the reaction rate will increase. And D is also correct because absorbance will actually increase as NADH is being produced. So Pramath, would you like to share the trick that you learned when you were reviewing?
Yeah, sure. So basically, I mean, like, so I'll give like an example. So I was not too sure about B and C because I was not too sure about it. But the thing was, I'm pretty sure like if you go back to the passage, like on the first slide with the graph, can you show that slide? Yeah. So for example, if you can see like at like C40, like any DH has a slightly higher peak than any D plus. So that means that in the process, what happens is that any DH is being produced, so then there'll be an increase in the absorbance. So down is true. So but like the only one so we know that any DH is being produced. So that means that that means also that any D plus is not being produced, and that's why A is wrong. So like, yeah, I think that's
right.
pretty
Yeah, you're correct on that. That's very helpful. So the options are actually, I guess I made a mistake when I was writing the slides because the document that I gave you, those were screenshots from the Khan Academy website, and I guess I must have put them in the wrong order for this slide, but I think the questions are written the same, just a different order. So I'm sorry about that. And next final question. Okay, so this is more of an orgo question, like you mentioned before. So this is why it's a good idea to be on track with all of the 3 sections content review and refresh your memory on all 3 consistently. So I highlighted the word low pH because this question is asking you what would happen at a specific condition. So there are many instances where I'll misread the condition or think that low pH means a low concentration of hydrogen. So always a good idea to pause for a moment and focus on this condition and what it implies. So B was the correct answer for question 5. And for questions like these where you have to kind of predict an answer, it's a good idea to find evidence. And in order to find evidence, you have to refer back to the passage. So the passage did tell you that pyruvate decarboxylase requires 2 cofactors, magnesium and TPP. So TPP forms a carb anion, and that attacks the substrate. So the passage is telling you that this is crucial for this step of the reaction of converting pyruvate to acetaldehyde. And the next step requires NADH, so C is out. Magnesium doesn't play a big of a role as TPP, so you don't have evidence that it's not present at a low pH. So D is out. And carb anions are very negative and unstable, so they'd be immediately protonated and fail to carry out pyruvate decarboxylase catalysis. So B would be our answer. And there's no evidence for A that pyruvate is not present at low pH. The passage doesn't imply that, so we can cross that out. Does anyone have any questions about eliminating answer choices or reading the passage in the question? Okay. So I think Sim is going to take over now.
Yeah, I'm gonna share my screen. Okay, and can you guys see this? And this is the second passage that we're doing. You guys can go to jackweston.com, Khan Academy, and under chemistry, click radioactivity of iodine 131, and I'll time you guys. So let me know when you're ready. Was everyone able to find the passage? You go to jackweston.com and click on the top, Khan Academy. I also sent the link in the chat. So if you just click on that, it should be like the 6th passage. If you just click the link that I provided in the chat. Okay, and I will start the timer. Okay, so we'll go over it now. And what did you guys get for question 1? I'm actually going to go to the passage. Oh.
Is it 16 days?
Yeah. Okay, so the answer was 16 days. Do you guys understand how to do that? Does anyone else have any questions? So I'll just briefly go over what this question was about. This is like a basic half-life example question. So in this graph, it says that the half-life of iodine decay is about 8 days. So going from, let me annotate this. So from half-life 200 to 100 grams would be around 8 days. And then going from 100 to 50 would be another 8 days. So that would in total be 16 days. Okay. Is everyone good on that? Okay. Next question. Oh, let me. Okay, what did you guys get for that?
Beta decay.
Beta decay, yeah. This is important to know the different types of decays. So beta decay is increasing the atomic number by 1, and that's what happens here. You can see the number of protons increased from 53 to 54, and yes, a neutron got converted to a proton. So the atomic number went up, and that is an example of beta decay. Positron emission would be where it would decrease by 1, where the atomic number would decrease. So that's not an example of this. Electron capture is also decreasing, and alpha decay is decreasing both the mass and the atomic number. So it's this is not an example of that. Do you guys have any questions on that? Or on the passage in general? Okay, if not, I'll keep going. For number 3, what was the answer for this? Or what did you guys put? B, okay, yep. So isotopes differ by the number of neutrons. That is something you should definitely know. Okay, does anyone know what a positron is though? So when you're going over the passages, just make sure you know what all the answer choices mean, just in case it does come up next time. Yeah, it's an electron with a positive charge. Yep, so it's like the same mass, but different charge. Okay, number 4. What did you guys put for this? D, okay, yeah. So this was fairly simple. You would just go back to this graph where it shows you the decay of iodine into, and then you would add up the energy. So this is a 2-step process. So you would have to add up both the 600 and the 360, kind of 64, and then that's around 970. Okay, what about 5? Okay, so first of all, this has an extra proton. We know that, so we can eliminate B and D. So we need to figure out, is it going to weigh more or weigh less because it has an extra proton? So this is kind of going back to periodic trends. So when a proton is added to the nucleus, so that means the electrons are being pulled closer to the nucleus, and this force of attraction actually decreases the size of the atoms. So this will actually weigh less and not more because of that periodic trend of atomic size and radius, that when you add a proton across the period, it will actually decrease the mass. Let me know if that kind of makes sense or not. So that's going back to your periodic trends. So if you knew that, that would have helped as well. Do you guys have any general questions about the passage? What is the answer to 4? 970. You would just add the two energy levels here, 606 and 364.
I have a question like overall like about like the passages.
Yeah, what's
So
up?
like for example like some of these questions are really like straightforward and I don't need that like actually read like the text. So like I was just thinking like for science passages, do you need to like exactly read the text to save time?
Oh, you mean the passage?
Yeah, so it's I mean like if you basically know like all the answers already, like for the questions, I mean, do you need to actually type like I mean sure question one like you kind of need the graph and then the other one for the energy, but I mean like do you need to like basically read like all the other text?
Okay. Yeah, like if you see a question and it's just like a freestanding question, you don't need the passage for those, and you can save time by not referring back to the passage. But sometimes there will be specific passage questions, so then you can start reading the passage. But I usually just like to read the passage just in case there are questions, because most of the freestanding questions are in the middle usually. But if you just see the question and it looks like you can do it right off the bat, it's more of a personal preference.
Okay, because I was thinking because I mean, most of the text, especially like in the first paragraph, has nothing to do with the actual questions. So
Yeah.
like,
This one does kind of have to do with the question or the passage, because you have to go back to the graph and see that the decay takes around 8 days.
well, yeah, but I guess like that's it.
Yeah, that is it. But, it's not like totally freestanding. You do have to go to the passage and the graph.
Sure.
Okay, what's your question about 5?
Yeah, so I thought it was bigger because Nina has a bigger mass number.
Yeah.
So wouldn't that weigh more?
Right, but technically as the protons are being added, so you have the same electrons, and they're actually being held closer together in the nucleus. So the size of them kind of shrinks because they're being held tighter because of that extra proton. So there's that extra positive charge that makes the electrons move closer together, and then that's why the atomic mass actually decreases as you add protons across a period.
Okay.
So
Okay.
mass increases so actually the mass does increase from left to right, but in this specific case, when you add a proton, it actually shrinks the how close the electrons are in the nucleus. So we can go back to that.
Oh, okay, I think I just got confused between. I thought you were just talking about the iodine as like an element, like not iodine 131. So I think that's why I got confused with the mass number.
Yeah.
Okay, thank you.
Okay. Does anyone else have any questions on this passage or the one Ashley discussed, or just in general, any passage questions? And this was just the trends for question 2. I put up a picture about the different types of decay that could have helped you answer that question if you were not familiar with this. Okay, we have a few more minutes, so let us know if you guys have any questions or anything you want to address. Okay, Ashley, do you have anything else to add?
I don't, but this chart is actually really good to memorize because if you have all of these memorized, it'll help you a lot during the exam.
For sure, yeah. I think definitely like beta decay, alpha decay, those show up a lot.
Yeah, and it's also like kind of, I don't know, I always got those mixed up, so.
Yeah. Okay, well, if you guys don't have any questions, we're gonna wrap it up. So some final reminders are you can join our Facebook group here and ask any questions on there as well. And here is our GoFundMe again. So please help out if you're able to, or even if you can just share the GoFundMe on your social media, that would be really helpful. And always, like always, just email us at mcat101questions@gmail.com. This is actually a typo. I will fix that before I send this out.
Also, the Facebook group is helpful if you want to find someone who is on the same schedule as you, so you can practice together, calm each other down, you know, rant to each other. It's really great to have someone who is going through the same things you are.
Yeah, definitely. If you need any like study buddies or any help like that, that would be super great to look out for. Okay, I think that is it.
Is there a class next week?
Yeah, we will send out a newsletter and that will have our sessions for next week.
Okay, cool. Thank you. Thank you.
Okay, thank you guys.
Thank you.